how I got 100 on my math exponents exam. So watch this video till the end to know exactly how to get 100 on your exam. I'm going to take you step by step through all the questions that I had, and I'm going to show you how to solve them correctly. So watch till the end because the most difficult question is at the end. Let's start off. Starting off with the first question, we have to find the greatest common factor of 20 and 80. So starting off with the 20, I'm going to use the factor tree. So 20 divided by 2 is 10, 10 divided by 2 is 5, and 5 is a prime number, so we stop. Now moving on to 80. 80 divided by 2 is 40, 40 divided by 2 is 20, 20 divided by 2, that's 10, 10 divided by 2, that's 5. So now that we have all our prime numbers, let's circle them, we can find the greatest common factor. To solve this, we need to make a table. So let's make a table where we have 80 and 20. We write all the prime numbers. So we have 2, 2, 2, 2, and 5. And for the 20, we have 2, 2. We don't have any more 2's. And we have 1, 5. We write it under the 5. Now, we only take down numbers that we have 2 of. So there's 2 2's, we take down 2. There's 2 2's, another 2. There's only 1 2 and 1 2, so we leave them up. And 2 5's, so we take 1 5. So now we multiply 2 times 2 times 5, giving us 4. 4 times 5 is 20. So the answer is B. Now on to the next question. Now for part 2, where we have minus 1 squared minus 1 power of 3. To solve this, it's crucial to notice that the minus 1 is not in brackets, so the squared does not apply to the negative sign. To solve this, you need to imagine that there's a negative 1 multiplied by 1 squared minus 1 power of 3. So the 1 squared stays 1. 1 times negative 1, that's still negative 1, minus 3 to the power of 3. 3 is an odd number. Therefore, it stays negative. So it stays negative 1. Then negative 1 into minus and minus become a positive plus 1, giving us 0. So the answer for 2 is B as well. Now let's move on to part 3, where we have to find the prime factorization of 200. To do this, I like to use the factor tree. So we have 200, that's the same as 2 multiplied by 100. And 100 is 2 multiplied by 50. 50 is 2 multiplied by 25. And 25 is 5 multiplied by 5. So as you can see, we have 1, 2, 3 2's. So it's 2 to the power of 3 multiplied by 1, 2, 5's by 5 power of 2, giving us the answer A, which is 2 cubed multiplied by 5 squared. Now on to the next one. For part 4, we have 8.5 multiplied by 10 to the power of negative 2. So it's 8.5 multiplied by 10 to the power of negative 2. When dealing with 10 to the power of negative 2, you have to move the decimal point 2 places. That's the same as this 0 here. So it's 0.085, giving us the answer A again. Now for part 5, we have 3 over 2 all to the power of negative 3. So if you watch my previous video, then this is really easy to solve. What you have to do is first expand, then simplify. So you have 3 to the power of negative 3 over 2 to the power of negative 3. Expanding further, you get 1 over 3 to the power of 3 is 27, all over 1 over 2 to the power of 3, which is 8. So to simplify this, we just multiply the furthest numbers and the closest numbers apart, getting 8 over 27. So the answer is C. Now moving on to the final question. For part 6, we have 5 to the power of negative 1 multiplied by 5 to the power of 3 multiplied by 5 to the power of negative 2. To solve this, because we're multiplying numbers with the same base, we add the exponents. So we get 5 to the power of negative 1 plus 3 plus negative 2, giving us 5 to the power of negative 1 plus 3, that's 2, minus 2, that's 0, which is 5 to the power of 0 is 1. The answer is A. Hopefully you're solving along and you got all the answers correctly. And if you didn't, hopefully you learned from your mistake and you can get it right in the exam. Now let's move on to question number 2. Moving on to question number 2, where we have to write the following numbers in scientific form. When you're asked to write a number in scientific form, that means there's one number before the decimal point, and then you can write all the numbers after, multiplied by 10 to the power of something. So let's start solving so that you understand what I mean and get the concepts better. For A, we have 0.372. So we need to write it as one number, then a decimal point, and then the rest of the numbers multiplied by 10 to the power of something. So we need to move the decimal point one place to the right, giving us 3.72 multiplied by 10. And because we only moved the decimal point one place and to the right, so it's a negative 1. If it was to the left, then it would have been a positive 1, because 3.72 times 10 to the power negative 1, that moves the decimal place one place to the left, returning us to the original number. Now for part B, we have 12 multiplied by 10 to the power of negative 3. This one can be a bit tricky, but let's go step by step. So 12, that could be written as 1.2 multiplied by 10. So the decimal point is here. We moved it one place to the left. That's 10 to the power of 1 multiplied by 10 to the power of negative 3. So that 1.2 stays the same, and when you're multiplying two numbers with the same base, different exponents, you add the exponent. So it's 1 plus negative 3, which is 10 to the power of negative 2. Hopefully you understood the concept, and we can move on to question number 3. For question number 3, we are asked to find the GCF, so the greatest common factor, and LCM, lowest common factor, of 24 and 54. So let's start off with the greatest common factor. Starting off with 24, using the factor tree, we can find that it's 2 multiplied by 12. 12 is 2 multiplied by 6, and 6 is 2 multiplied by 3. Now for 54, using the factor tree as well, we get 2 and 27. 27 is 3 and 9, and 9 is 3 and 3. Now that we have both factor trees done, let's circle all the prime numbers. We have 3, 3, 3, 2, 3, 2, 2, and 2. Now let's write them in a chart to help us solve for the greatest common factor and the least common factor. So the chart goes like this. You write 24 and 54, and then you write all the prime numbers you got. So it's 2, 2, 2, and 3. And for the second number, you start off with the 2. We have a 2 for the 54. We don't have any more 2's. So you go to the 3. We have 1, 2, and 3 3's. Now, for the greatest common factor, we take down all the numbers that we have 2 of. So there's 2 2s, so we take 1 2 down, and there's 2 3s, so we take 1 3 down. And we multiply. So for the greatest common factor, we multiply 2 times 3, giving us 6. Now that we have the greatest common factor, let's find the least common factor. To do this, let's erase the numbers we have here. Okay, for the least common factor, you take down all the numbers you have. So you have 2, 2, and 2, and 3, 3, 3. And you multiply them all together. So it's 2 times 2 is 4, 4 times 2 is 8, 8 times 3, that's 24, 24 times 3, that's 72, and 72 times 3, that's 216. So we can say that the least common factor is 216 based on multiplying all the prime numbers that we got. So here is greatest common factor and the least common factor. Hopefully you understood this concept. If you didn't, please comment down below and I'll try to explain it again in another video in more detail. Now let's move on to question number 4. For question number 4, we are asked to complete and justify our answers. So starting off with A, we have 9 power of negative 2 multiplied by 9 power of negative 7. So we have the same base, so we add the exponent. We have 9 to the power of negative 2 plus negative 7, giving us 9 to the power of negative 2 minus 7, that's negative 9. So over here, negative 9. Now moving on to B, where we have 5 power of negative 1 over 5 power of 3. So 5 power of negative 1, that's the same as 1 over 5. So we can take the 5 from the numerator down to the denominator. So we have 1 over 5 power of 3 multiplied by 5 power of 1. So now that we have two numbers with the same base, we add the exponents, giving us 1 over 5 power of 3 plus 1, which is 4. So we need to write it in the form of 5 to the power of something. So take 1 over 5 to the power of 4 and make it 5 to the power of something. We need to add a negative sign to the exponent, which gives us 5 to the power of negative 4. So negative 4 is the answer here. Moving on to part C, we have 2 to the power of 3 multiplied by 8 to the power of 4 all over 16 to the power of 2. And we need to write it in the form of 2 to the power of something. So let's try to simplify as much as possible so that 2 to the power of 3 multiplied by 8 to the power of 4. Let's start off with the 8. 8 is 2 to the power of 3. So you can write 2 to the power of 3 all to the power of 4 over 16. 16 is 2 to the power of 4. So we can write 2 to the power of 4 all to the power of 2. Now that we have it in this form, we can simplify even further. So we have 2 to the power of 3 multiplied by 2 to the power of. So once we have power to the power, we multiply the exponents. So we have 3 multiplied by 4, which gives us 12 over 2 to the power of 4 multiplied by 2 is 8. And to solve this, that's the same as 2 to the power of 3 multiplied by 2 to the power of 12 multiplied by 2 to the power of negative 8. So to do this, we add the exponents. So it's 3 plus 12, giving us 15, minus 8, giving us 7. So it's 2 power of 7. Let me make some space and we can solve D and C. For part D, we have 16 power of negative 3 and we need to write it in the form of fourth power of something. So 16 is 4 to the power of 2. So we write 4 power of 2 all to the power of negative 3. And once you have power to the power, we multiply the powers. So it's 2 multiplied by negative 3, giving us 4 to the power of 2 times negative 3, which is negative 6. That's negative. Finally, for E, we have 1 over 7 power of 3 multiplied by 7 over 2 power of 3. So, solve this, we first expand, then simplify, giving us 1 to the power of 3. We can write as 1 over 7 to the power of 3 multiplied by 7 to the power of 3 all over 2 to the power of 3. Simplifying this, we can cross simplify. So 7 to the power of 3 cancels out with 7 to the power of 3, giving us 1 and 1. So that's the same as 1 multiplied by 1 over 2 to the power of 3. And that's the same as 1 over 2 to the power of 3. 2 to the power of 3 is 8. So 1 over 8. 1 and 8. Hopefully you were solving along and you got all the answers correctly. And if you didn't, hopefully you learned something new and we can move on to question number 5. Now for the last question, the most difficult question in the exam, which asks us to evaluate the following numerical expression. So we have 25 power of 3 over 5 power of negative 2 multiplied by 5 power of 8 subtracted by 2 power of negative 3 multiplied by 8. Let's start by simplifying. So we have 25 is 5 power of 2. So we write 5 power of 2 whole power of 3 over 5 power of negative 2 multiplied by 5 power of 8 minus 2 power of negative 3 multiplied 8 is 2 to the power of 3. So we can write it as 2 to the power of 3. Now to simplify this even further, we can take the numbers in the denominator and move them to the numerator. So we have 5 power to the power, we multiply the exponents. So it's 2 multiplied by 3, giving us 6 multiplied by 5. Since we're moving the number from the denominator to the numerator, the negative exponent becomes positive. So it's power of 2 multiplied by 5 power of negative 8 because it's moving up minus 2 power of negative 3 multiplied by 2 to the power of 3. So now we have 3 5s, so the same base, so we can add the exponents. 6 plus 2 is 8, 8 minus 8, that's 0. So it's 5 power of 0 minus 2 power of 3 multiplied by 2 power of 3 gives us 3 minus 3 is 0, so it's 2 power of 0. Giving us 1 minus 1 because anything to the power of 0 is 1. So the final answer is 0. So this was my exam. Hopefully you learned something new and all your questions were answered. If you have any more questions, please leave them down below in the comments and I'll get to them in the next video. And if you have any suggestions for future videos, please comment them down below. Please like, subscribe, and I'll see you next time. Goodbye.